Good afternoon. Today we're going to see about the concepts of wedge friction. Wedge is a thin inclined plane shaped object which is used to apart or to split the object into two parts or to lift the object in upward direction. Here, the chisel is used to split the object into two, that is to split the object wooden block into two pieces. A force is applied on the upper surface of the chisel here. If you are applying a force over here, it will split this block into two parts. The direction of applied force in downward direction, therefore the frictional force will act in the upward direction. The normal reaction will always perpendicular to the contact surface of the any object. Normally the wedge is used to raise the load or to move the load in for a certain place. While solving the problem, we have to draw the free body diagram of the block and wedge first. Then we have to solve the problems. The direction of impending motion is very important in solving the problem. The direction of the impending motion, that is, when we apply a force, the frictional force will always act opposite to the applied force. When an object starts to move, then it is called as the impending motions. In that state, the object will not remain in the equilibrium conditions. When the object starts to move, the object will not be in the condition of equilibrium. In the impending motion, we can assume that the object is in the equilibrium condition. Let's see the question. A block of 1000 Newton is to be raised by means of force P, which is acting on both sides of the blocks. This is the force P, which is acting on either side of the blocks. The angle of friction of all rubbing surface is 15 degrees. This is the angle of surface. We have to determine the value of P. Here, for this condition, we can neglect the weight of wedge. The angle of wedge is given as 30 degrees. This is the angle of wedge. This wedge. So when the angle of wedge here to this point, we can consider it as 30 degrees. This is 30 degrees. So when we try to solve the problem, first we have to draw the free body diagram. Then we have to identify the angles. Then we have to go for solving the problem. First we write the given data. The weight of the block is 100 Newton. The given is pi is of 15 degree. To find the coefficient of friction, we have to use the formula tan pi is equal to mu. We have to use this formula tan pi is equal to mu. So we have to identify the coefficient of friction. Initially, let's solve the problem by completing the free body diagram. Just see here. To solve the free body diagram, first we have to consider the block. This is the block. The weight of the block acts perpendicular to the ground plane. Then there will be a normal reaction wherever the contact surface. So this is the normal reaction for block. Then when the block is moving, when the wedge is applied force of wedges in this directions, then the block moves in the upward direction. So when the block moves in upward direction, just imagine that the block moves in this direction. So the frictional force will be of in the opposite direction. Similarly, here also the frictional force in the opposite direction. Let's see the free body diagram of block. See here, this is what free body diagram of the block. The weight is in the downward direction, the normal reaction in the upward direction, with the normal reaction in the downward directions. This is nothing but frictional force. F is equal to mu into NR. Here it is F2. Therefore, F2 is equal to mu 2 into N2. As already said that we have to calculate the mu value as tan pi is equal to mu. The tan pi, it is given as tan 15. Tan 15 is equal to mu. So we'll get the mu value as 0.268. So they have substituted the mu value. Let's see how this angle was calculated. As already said that this angle is of 30 degree, then the angle between the normal reactions and the weight will be also of 30 degree. So with respect to horizontal, it is of 60 degree. Then we draw horizontal line over here. It will be also of 60 degree. That is what given in the diagram. 60 degree. When we draw with the horizontal line, it is also of 60 degree. This is what given here. When we go for wedge, the wedge is in contact with the block. So what we assumed for the block is in the upward direction. So for the normal reaction in the downward direction. Similarly, N1 and N2. Here the applied force in this direction. So the frictional force is in the opposite direction. This is how we have to draw the free body diagram. Then this free body diagram can be drawn in the line diagram as here. As we've seen that the N2, here it is inclined at 30 degree. The N2 over here will be of 60 degree. Then N1 over here is of 60 degree. The N1 here is of 30 degree. This is the 1000 Newton. So here also for the wedge, we have drawn the line diagrams. Then first we have to solve the block by applying all the values. Free body diagram of block. Sigma fx is equal to, by considering the horizontal directions, n1 cos theta plus 0.268 n1 cos 30 minus n2 cos 60. We'll get the value as 0.268 n2 cos 30. Here the n1 and n2 will be of same. Similarly, sigma fy is equal to n1 sin 60 plus n2 sin 60 minus 0.268 n1 sin 30. n1 is equal to n2 is equal to 683.036 Newton. We'll get the n1 and n2 value as 683.036 Newton. Similarly, sigma fy for the B, that is wedge. We have to consider any one wedge. Sigma fy, we'll get the equation as n3 minus n1 sin 60 plus 0.268 n1 sin 30 is equal to 0. We'll get the n3 value as 500 Newton. When we substitute the n3 value in the resolving equation of sigma fx, we'll get the value of P. The value of P is equal to 634.047 Newton. Thank you.